Hi, everyone. Welcome to this edition of ProjectPro Expert Talks. We are honored today to have with us Kranthi. Kranthi is a senior data scientist with almost 15 years experience setting up and scaling data science teams from single-member team to a team that supports large multi-billion-dollar startups out there. So Kranthi is currently the senior principal data scientist at Oyo, where he's going to start focusing on pricing and revenue management problems. Before this, Kranthi spent 6 years at Swiggy, India, or probably even Asia's largest food delivery startup. He started setting up the data science team at Swiggy literally a year after they started. He grew the team. He spent 6 years there, and more recently, he was the AVP for data science at Swiggy. Before that, Kranthi spent many years at 24/7, working on both ad tech and conversational chat platforms. Kranthi has a PhD in operations research, and I tried counting the number of patents and papers Kranthi has. I got to about 22, then I roughly stopped. So 22 plus patents and papers in this area. So Kranthi, thank you very much for taking time to do this.
My pleasure.
So Kranthi, as part of your experience, one of the things that you've kind of done is under the umbrella of Vika, you've kind of helped startups in a consulting role to scale their teams. The question I had is there a specific metric or inflection point or a scale at which a startup suddenly feels they need data science capabilities? How do you make that decision?
So it's dependent mostly on the founder or founders, or right, as well as the nature of the problem, right? For example, right now, if we look at tech, there are a lot of companies, but in India. But the need for data science in that tech companies is probably not very visible because they have more fundamental problems to solve, or mass marketing is working. So the value what data science brings is very, very contextual. But every founder in the present age will feel the VC pressure of having a good AI, data science, analytics team, irrespective. Right, and that's as soon as you go Series A plus, I think everyone would want to start doing that. So I would say it is the inflection point is not the need of whether they have the data or not, or whether they have the right problem to solve or not, but it is about getting the right 1-2 people first, or identifying the first problem to solve. And convincing the whole organization that, hey, this path will continue, right? And to be honest, I think the failure rate will also be very high in terms of showing value to the organization, because it takes time, it takes systems to be set up and all. But nonetheless, earlier you start the journey, the more probability of success in the long term.
Okay, understood. And when these companies do decide to start data science capabilities, what are usually the first problems they tend to tackle? Is it pricing usually, or?
So at that point of time, whatever is the pain point for them, that becomes the biggest problem. It can range from recommendation to trust and safety, to something very core to them, like depending upon the startup. So if they are into some gene therapy with AI or some DL with AI, then that becomes their core, right? In some cases, it's their core problem statement, but many times it is the biggest problem which they are facing at that instance where they would like to take the support, right? It can be something which the customer, if they're customer facing, the customer is driving, or something if they're B2B in that space, whatever they think will give them the edge in their metrics.
Understood. Okay. And you briefly spoke a minute back about there are lots of failures as well in turning this into business value. And talking about turning it into business value makes me kind of think about actually the deployment of these models into production. And right now, the term MLOps is all the rage right now, right? So my question to you is, even before this term MLOps came in, people were deploying models, right? What is MLOps? What is the difference between pre and post that term coming into function?
I think all of us are agreeing on a standard and making it a subject, like that is what it is. So any field goes through this evaluation. A very old example would be like the semiconductor wafers, right? So when people started manufacturing chips, there were no standards at all. Everybody had their own standards. Or VHS, there were different standards, CD, different standards, music, different standards. Then a body comes in and says, we need to establish standard, and you go through that rhythm, right?
Okay.
So I think that is a natural progression. That is what it is. And it's good that that is happening, because the best practices across the board are coming together. Otherwise, it would be somebody's experiences versus somebody else's experiences, and whether it will suit or not. The other aspect is, because now it is standardized, you can commoditize. Or you can provide tools. Now, if you provide tools and commodities, it's easy for the latest or even the previous data scientists to leverage them at scale. So the same thing of monitoring models, which probably we did in production, which we did in 2011 at 24/7 by having some SQL servers and Prometheus alerts and things like that. Now is readily available at a click of a button through Grafana, through either GCP or AWS or Azure, right? So that's amazing to see that progression, and also related coursework coming up on that, right? Like I think summer 2021 summer, there was something on ML lifecycle, Stanford course, which was amazing, right? So I in general, it's a natural progression. I think all of us who have been in this place for a long time have done enough mistakes. And now if I actually have this cheat sheet, it feels, this is what we were looking for.
I see. Very, very, very interesting. That's a very interesting perspective. And given that you've been towards your journey of becoming a senior principal data scientist, you've been doing this as a data scientist for a while, right? And you've probably seen a lot of these standardizations happening over the years. What has changed in data science as a job role profile? What has materially changed?
So I think the expectations are much higher nowadays, right? For example, if you go to teachable machines and quickly click, within 5 minutes, you can have a ready-made face recognition or image recognition or gesture models, right? And then you have Siri daily and all of that. So that whole technology evolution gives a perception that, hey, it's not that difficult to get things into production. Whereas the reality is, unlike specific use cases, most of the time there is enough iteration required, right? So the client's patience levels, or the customers or the leaders, business owners, their patience levels have decreased, right? That's the con. But on the pro side, the number of tools which is available to do this has increased so much, and the talent has increased so much because of these tools or the courses available or YouTube or what you are providing, right? That it's much easier to get things done right now. So the same thing which would probably take 6 months to a year, probably 5-10 years back, now can be done in even 2-3 weeks.
Wow.
Right. So that's a huge change. So there is a reality to it, but that doesn't remove, that's the only tech part, right? You have the initial, okay, are we solving the right business problem? The why is hows. the data part, that we can't cut time. And the iterations, you can't cut time. Only the in-between part of taking an idea to a POC to production, I think the time can be cut. So still, I would say that's where the gap is with respect to what people are thinking, that AI is the magic bullet. Though many people now realize it takes time, right? As I mentioned.
That's very helpful. So since we were talking on the topic of saving time and tools to get all these things done faster, what role in this equation do AutoML tools play? H2O, DataRobo. When do you choose you want that versus doing it yourself? What are those scenarios?
I myself, or the teams I have worked with, have used those tools more as benchmarking.
I see. Okay.
Right? So if AutoML is giving X, the data scientist or the work a data scientist is doing is only valuable if it crosses X in terms of precision recall and all. Right. So that becomes your benchmark. Previously, the benchmark would be an iBase or a logistic or something else, right?
Right.
Now you just throw the tool at it.
Right.
And now you see, can you beat the tool? Right. And obviously you have to, either one way or the other. Right. That's one. The second difference is the number of problem statements. As it increases, not everything is a priority. Some of them might not be priority, but are important to solve. Those problems, obviously, you can use AutoML, right? So it empowers anybody, engineer, product manager, a business analyst. Anybody can just try and get some metric, and that can be your P1 or first model to try out in production. So that's the beauty I see, especially with any of these AutoML practices. In fact, some of the Kaggle competitions, if you take the data set, put it in AutoML and plug it back in, at least you won't reach the top, but you will reach the top tier, definitely.
I see. So it's a good way to get badges. Right. Okay. Great. That's very helpful perspective. So Kranthi, you yourself are a pretty strong believer and proponent of the data-centric approach of looking at a data science project before jumping into actually writing code. Could you maybe just help us understand what data-centric approach is, what inspired you to believe strongly in it, and
So I have been a data guy from the very beginning of my career, even before the word data science was termed, right? And over time, it has been a pleasure working in different use cases where first you start collecting the data, right? Are we collecting the right data? Is it coming the correct way? Is the data getting corrupted anywhere? These are the basic things which nowadays I think data scientists take for granted, especially even in startup environments. But those are where, for example, let's say you launched an app, but you're not collecting location data. The question should be, why not? Can I take location data and use it for something for the user? That should be the natural curiosity. So think data, respect data. If you collect the data, use the data. That is the larger philosophy. In the latest movement, which Andrew NG has started, I think in 2021 or 2020, right? Where it's everything to do with better labeling of data. So once you collect data, it's not useful until you massage it properly, you label it properly, spend the time and energy to understand each data element. And there are multiple examples around that, right? So as simple as alphabet detection, right? Handwritten alphabet detection. You spend 3 hours just cleaning the data, probably the accuracy will improve decently well, which you would not do otherwise, right? So most of the time we don't even look at what the error is and how the image is looking and what the original the prediction is coming, different predictions are coming, right? So that's something which is being talked about, especially from causation and all those perspectives to understand. But even in structured data, that is true. Right? Even in structured data, if you're getting a prediction and it is way off, why it is? Is it a data error? It is outlier? What is happening? We don't try to spend enough time on that. Now, if you humanize those things, and say every wrong prediction is going to cost someone something. Let's say it can be loan interest, it can be wrong time predicted somewhere or something else. And you say that is me who is at the receiving end. Then I think data scientists will spend time understanding what's breaking in the data flow. So it's, I'll stop there.
That makes a lot of sense, just being a lot more thoughtful than jumping into and constantly tinkering with the model.
Yeah, so just like how many nulls are there, how many outliers are there, what is the summary stats? Though all those are there in Kaggle codes and stuff, in practice, I think people just, don't use it as much.
Okay.
And when, for example, if you're doing an A/B test, people don't look at a lot of statistical significance. You don't do AA test. All these are part and parcels of hygiene, in my opinion.
Yeah. Great. And on that note, Kranthi, obviously, since you believe in this so passionately, I'm sure when you hire people to your team, you somehow figure out, you assess this in them. So how do you assess this? What else do you look for before you hire someone?
So one of the traditional mechanisms I keep following most of the times is usually case study is a standard approach in data science, right? The case study here is not to give a problem statement and ask the person to solve, but give a data set and ask the data scientist or potential data scientist to come up with a problem and provide a working code.
Got it. Oh, okay.
So then you actually have to look at the data to come up with a problem, right? In reality, that is what is happening, right? You need to think about a problem. Conceptualizing a data problem is a key skill of a data scientist.
That's very interesting. Saying, here is all this data, what value can you extract from this?
Yes.
Right? Okay.
Yeah. So many people just do clustering, right? Or do summary stats. That's okay. That's a good start. But you need to wear a product hat, a business hat, and think, okay, what can I do with this column, assuming it's not available or something else? Is there merit in predicting something? Or are the clusters telling me a story? Can I convert them to some actions? Right? That end-to-end storytelling is what is missing most of the times. So that while sometimes that works, if that doesn't work, what we look for is whether it's usual verbal communication interviews, right? Mostly whether the person is up to date on the field. If a person says I'm an NLP expert and he or she doesn't know about GPT-4 and the latest issues which are happening with OpenAI and all of that, then that's a red flag, right? So it's basic, right? So you need to be aware of the SOTA if you're a specialist. If not, you need to be aware of at least some of the best things which are happening in the field, the news. You need to have I would say, a figure you admire, so you can follow, because this is an evolving field. How are you keeping pace with the latest changes? All of these things are key, like curiosity, then technical knowledge. All of them are obviously there, but curiosity is very important, right? And eagerness to continuously learn, irrespective of number of years of experience.
Right. Maybe one of the final questions I have is, what kind of efficiency tips and tricks do you have in your bag of this thing that you accumulated over the years to kind of get your work done more efficiently, faster? Any guidance on that?
So this is a very slightly philosophical thing, in the sense that we usually try to focus on things which we are not good at and try to improve on them, right? Okay. Like, let's say I'm not writing a structured code, or my order complexity is not good. I would try to improve on that, rather than, if I'm good at data, trying to leverage my strength at that. You're usually working in a team scenario, right? And every team member has their strength. Some people are good at data. Some people are good at visualizing what is the larger problem. Some people are good at communicating, tracking the projects to closure. Some people are good at MLOps. They have the rigor. They can pick up the phone anytime.
Yeah.
Some people are good at coding, right?
Yeah.
Key thing is to keep leveraging that strength more and more in the team. As you keep leveraging that strength more and more, and keep working on the weakness right, a little bit, I think the balance comes, and that's when the team performs to the best of their capabilities, right? Being the best version of each one of them. Now, individually, if I have to hack something and I have X amount of time, the maximum amount of time I spend is just feeling the data, trying to do simple things. Like if it's a word problem, NLP based, what is the TF-IDF looking like? How is the distribution? Then what are the embeddings looking like? And mostly using pre-trained models as much as possible after feeling the data, right? But definitely the amount of pre-trained models which are available or AutoML tricks which are available, those are the ways I think we can easily circumvent a lot of stuff. Here is an example. If somebody gives you a data set and they're asking for 95% accuracy on something, the first thing is you just throw it to AutoML and see what is the accuracy if that is giving you. If that's giving you 67, I don't think there is any way with the data provided you can hit 95. Right? So that becomes a different conversation. Then you say, why do you need 95? What are you actually looking for? So solve the right problem. So it's always solving the right problem, wrong problem where most of the effort is gone.
Right. That's a fantastic insight. Yeah. A lot of leverage in picking what problem to solve, right?
Yeah.
I can totally relate to it as an entrepreneur in a startup, and I guess similarly in data science as well. I think significant leverage from working on the right thing.
Yeah.
Okay. And I said it was the last question, but maybe one more. What are some signs that what you are working on is the right problem? What are some early indicators of that? I know that over the years you'll get some intuition for it, but otherwise, can beginners see any early signs to indicate?
You will feel, I think you should talk about the problem with your colleagues or friends, right? Whoever in your network, and say, I'm trying to solve this kind of problem. This is what it is. As well as try to explain it to somebody who is not in your field. Like I try to explain it to my family members or cousins, and they're like, why are you even solving it? Why can't you hire 10 people to do that thing? Okay, I don't have an answer to that. Right? So while that is one, when I talk to data scientists and they give a viewpoint, there is this approach which has come out, probably you should try that. So I think communicating and talking within your network about that problem specifically in very layman terms is key. If you're not able to, I think there is that saying, right? If you're not able to say the problem in 2-3 lines or whatever, then you're overcomplicating the problem. So the early signs is that if you're able to say that and majority of the people think it's a good problem and you're making progress, then it's good.
Fantastic. Very, very helpful, Kranthi. So just to summarize, pick the right problem, evangelize and talk about the problem to people to get inputs. Once you start working on it, get a feel for the data, get a sense of what you're trying to do rather than just jumping directly to coding. Okay. And, use AutoML tools as a benchmarking pointer. Super. Thank you very much for your time. Really appreciate taking time to do this.
Thanks for having me. It was a great discussion. Best of luck.
Bye, Kranthi.